All right, today our objective is to be able to use the properties of parallelograms to solve problems using them, to find angles and sides of parallelograms using the properties. So most of these properties you're already familiar with. What makes a parallelogram is that its opposite sides are parallel. Now that's going to create a lot of things for us. If AB is parallel to DC and AD is parallel to BC, remember we mark that things are parallel by using those arrows. These two are parallel to each other. These two are parallel to each other. Now, why that's important to us is because it creates a lot of like alternate, everything that goes with parallel. We have alternate interior angles, alternate corresponding angles, same side interior angles are supplementary. And so we have a lot of those things that we used with parallel lines that we can use now. Just to touch on it really quickly, what that means is that maybe angle ABE is congruent to angle CDE because those are alternate interior angles. So we can trace those sides. And so we're going to get that situation when we're dealing with all of our angles, which is nice. Okay, because it's something we already know. We've got that our opposite sides are congruent. So not only are they parallel to each other, but they are also congruent to each other. Remember that we mark congruent pieces in the same fashion with tick marks. So these two are congruent to each other. AD is congruent to BC, and AB is congruent to DC. Okay, now we get into, those are the things with our sides. Now we get into our opposite angles. Our opposite angles, opposite means across from each other. So A and C are opposite of each other. They are congruent to each other. So this angle altogether is congruent to that angle. And this angle, ADC, is congruent to ABC. So we have that those alternate or opposite angles are congruent. Because the lines are parallel, we have that our consecutive angles are supplementary. Consecutive means one right after the other. So A and B equal 180. B and C add up to 180. They're supplementary. C and D are supplementary. And A and D are supplementary. Okay, and that's because they are those consecutive interior or same side interior angles for parallel lines. And then probably the newest information that you're going to see today is that the diagonals bisect each other. It means that they cut each other in half. So DB is a diagonal, think of it like a knife, and it cuts AC in half, meaning that AE is equal to EC. And then AC is the knife that cuts DB into two congruent pieces, or cut it in half, bisect it. And so DE is congruent to EB. So let's take all of those and let's put them into practice. So we're going to start here, find the sides and the angles of parallelogram ABCD if AB is 8, BC is 15, and the measure of angle A is 68. So let's go ahead and label on our picture everything that we know. AB is 8, BC is 15, and angle A is 68 degrees. So we're going to put our 68 degrees. Those are the pieces of information that we know. So I want to find the rest of it. So AD. I notice that AD is opposite of BC. Opposite sides are congruent to each other. So AD is 15. I like to label things on my picture as I find them so that I can keep up with what all I have already found and how I've used it in case I need it again. Then DC. DC is opposite of AB. Those two sides are congruent, which means that CD is also 8 because opposite sides are congruent. Then angle B. Well, angle B, look at A. Here's angle A. We have angle A. Angle A and angle B are consecutive angles, which means that they are supplementary. So if I take 180 and subtract 68, I get that angle B is 112 degrees. Those are same side interior or consecutive interior angles with those parallel lines. C, angle C. So there's two ways to find C. It's either supplementary to B or it's equal to A. Opposite angles are congruent. A is 68, therefore C is 68. And then D, again, D is same side interior or consecutive angles in this. So with C and D, or A and B are supplementary, or B and D are opposite angles that are congruent, which says that angle D is 112 degrees. So that is using opposite sides are congruent, opposite angles are congruent, and consecutive angles are supplementary. Now let's look at this one, and we're just going to start with what we know. We know that RT is 30. So this whole thing is 30. I'm going to put my 30 right in the middle. Notice RU is already labeled with 18. RS is already labeled with 27. So UT is from here to here. Well, what I know is that this diagonal, US, has cut this diagonal, RT, into two congruent pieces. So if I go in and I label that, I know that VT, or excuse me, UT, I'm sorry, I saw that as a U, that's a V. UT is right here. UT is opposite of RS, that's 27. So RUT, excuse me, is 27. ST is this side. It's the opposite side from the 18. So ST is 18. VS is right here. Notice that VS is this small piece. It's part of the diagonal. The other part of the diagonal is 7, which means that same part because the diagonals got cut in half. Each of the diagonals was cut in half. So VS is 7. And then now back to the VT that I was talking about before. If the whole thing is 30 and it got cut in half, that means that each of those pieces is 30 divided by 2, or 15. And so those use that the diagonals bisect each other. Opposite sides are congruent, and the diagonals bisect or cut each other in half. Okay? Now let's look at one that has to do with some algebra. Solve for x and then find Ln. So if I look at these two, I know that these are opposite sides of a parallelogram. Because it says each quadrilateral below is a parallelogram, we have to know that information. That means that they are equal to each other. These two pieces are equal to each other, or part equals part. 9x minus 25 is equal to 5x plus 7. If we go through and we do the algebra for that, we subtract 5x from both sides, add 25 to both sides. 4x is equal to 32. If at any point you need to pause the video, go ahead, divide both sides by 4, and you get that x is 8. If x is 8, then how long is Ln? Well, Ln is 9 times x minus 25. Well, x was 8, so it's 9 times 8 minus 25. Well, 72 minus 25 is 47. So the length of Ln is 47 units. That is using that opposite sides are congruent to each other. Okay? So we start by just looking at what we've got, TV. TV is the whole diagonal. The whole diagonal all the way across is 74. WV, notice that WV is only part of it, is 4x plus 1. Now there are two ways to look at this. TW plus TV is equal, TW plus WV is equal to TV. TW plus WV is equal to TV. These two pieces give you the whole thing. Part plus part equals whole. Now what I gave you is I gave you the whole thing and a part. You cannot set those two equal to each other. But there are two things you can do. You can either do 2 4x plus 1s equals 174, or you can take 74 and divide it by 2 and find out that each of these pieces is 37 because the diagonal got bisected. So what you could do is you could say, well, part equals part, or 2 parts equals the whole, whichever way makes the most sense to you. keep my numbers smaller if I deal with half. And actually in this case it worked out pretty well because 74 is an even number and it divides easily. Subtract 1 from both sides and you get that 4x is equal to 36. Divide both sides by 4 and you get that x is equal to 9. Okay, so what we wanted to know is what is the x value that has to exist so that this piece can be 37 so that the whole thing can be the 74 that I said it is. The diagonals bisect or cut each other in half. Okay, if ABCD is a parallelogram, if angle B is 6x minus 21, so I'm going to label that 6x minus 21, and angle A is 4x plus 11, find angle C. All right, so let's start. Before we can find angle C, we have to find x. So the relationship between these two angles that I have information about is that they are consecutive interior angles, which means they are same side interior angles for these two parallel sides, which means they add to 180. So 6x minus 21 plus 4x plus 11 equals to 180, or 10x minus 10 is equal to 180. Now, I just combined my like terms. 6x and 4x is 10x. Negative 21 plus 11 is minus 10, and those equal to 180 because they are supplementary angles. Add 10 to both sides, and you get 10x is equal to 190. Be careful, everybody always wants to subtract that 10 from both sides. It's already subtracting. You need to do the inverse. Divide both sides by 10, and you get that x is equal to 19. Be careful. That is not what I asked for. I didn't ask for x. I asked for the measure of angle C. Well, angle C is the same as the angle A. So if we find angle A, then we'll know angle C. You could also use that it's supplementary to B, but being equal is easier. So if I take 4 and I multiply that by 19 and I add 11, that will give me how big angle C is. So angle A is 87, which means that angle C is also 87 because opposite angles are congruent. Then lastly, WZY. Let's find WZY. So we start at W, we trace to Z, and we trace to Y. So this entire angle right here is 62. That whole pink angle is 62. Zoom in a little bit to make it easier to see. Then WXT, W to X to T, right here, this piece is 27. And then our last piece, ZWT, Z to W to T, remember W is our vertex, Z to W to T, this piece right here is 77. All right, so there are some pieces that you want to find, so let's look at what we're being asked for. ZWX. ZWX is this whole angle. I want to know how big this whole angle is. Well, if you look at it, this is kind of like a puzzle. So look at what you have. I don't have this angle, so I don't have angle 1. But what I do know is this. I know that this angle here and this angle here are consecutive interior angles. So ignore the 77 for a minute and just say, okay, well then if this is 62, then 180 minus 62 is 118. Oh, not 118 degrees. That should have been tiny. So this whole angle, this whole yellow angle right here is 118 degrees. Well, now you can see if you know the whole thing is 118 degrees, then this 77 plus this angle 1 should be 118 degrees. So now I can see if I take that 118 degrees and I subtract the 77 degrees that I was given, then that will give me 41, which means angle 1 is 41 degrees. It is always a good idea to go in and label all the pieces as you find them so that you don't have to rethink about it again later. Okay, so now I want angle 2. So I look at angle 2. I don't know how big this angle is on this other side, so I can't subtract anything. But what I do notice is that I've got this 27 up here. Now the reason that that 27 might be important is because we know that these two are parallel to each other. If those two are parallel to each other, then I know that these are alternate interior angles. And if the lines are parallel, then alternate interior angles are congruent. So what that tells me is that angle 2 is 27 degrees. This from here to here is 27 degrees. Okay, alternate interior angles. Those are very important and very useful. And then x, y, z. So I want to know how big x, y, z is. X, y, z is this whole angle right here. That whole angle. Well, if we go back to alternate interior angles are congruent, those alternate interior angles are congruent, then this angle is 118, so that makes this angle also 118. So angle XYZ is 118 degrees. So remember, alternate interior angles are congruent, and then because the sides are parallel, same side interior angles are supplementary, and alternate interior angles are congruent. Those are going to be important things. So in summary, you should be able to answer this question. The diagonals in a parallelogram, what do they do? What do the diagonals in a parallelogram do? And then what do same side angles inside the parallelogram do? Think about that for a second. Pause it. Diagonals in a parallelogram bisect each other. And same side angles are supplementary. It means they add up to 180 degrees.